Hello everybody, welcome into another lesson. So today we are going to do a little bit of graphing in the three-dimensional coordinate system. The idea of today's lesson is to prepare you actually for the next lesson, which is going to be about solving systems of equations with three variables. Well, we want to show you graphically what's going on when you have an equation with three variables, a linear equation that's got three variables, and solving a system for them. So here you're used to the two-dimensional Cartesian plane, which has just the x and y axis. Well, here you have your x-axis, which runs diagonally. You have your y-axis, which runs left to right. Then you have your z-axis, which runs up to down. That's the three-dimensional Cartesian coordinate axis, the grid, the three-dimensional grid. So now we have it in 3D. And you're used to an x and a y coordinate, which is an ordered pair. Well, in the three-dimensional, you have an x coordinate, a y coordinate, and a z coordinate, which is called an ordered triple. You'll move in the x direction first, then in the y direction, then you'll move in the z direction. So you add the z dimension to this whenever you're plotting points. So let's just plot a few points here. We'll start off just by plotting a few points. Let's say we had the point 240. Of course, this ordered triple 240 tells you you're going to be positive 2 on the x-axis, which would be right here, then over 4 on the y-axis, and then 0 on the z-axis, which would put you right about there. It would put you right about there. I know it looks like it's on the z-axis, but it's not. Plotting these in 3D is a little bit tough, but there would be the point 240, because you've gone up z, but you've gone over 2 and up 4 on the y-axis. Up 2 over 4 on the y-axis. So it's a little bit different when you're plotting in 3 dimensions. What about if I plotted let's do 4, -1, 6. Let's plot the point 4, -1, 6. Well, where's that going to be? Of course, you're going to be positive 4 on your x-axis, -1 on your y, which would put you right about here, and then 6 on your z-axis. So you're going to be roughly in here for 4, -1, 6. It'll be roughly in there when you plot in 3D. And I know this isn't the best because it looks really two-dimensional. It's actually very hard to draw three-dimensional, at least for me. I'm not an artist, in case you haven't figured that out. How about 0, 6, -3? So we'll plot 0, 6, -3. So you're over 0 in the x, but you're over 6 in the y, which would be right here, the -3 in the z, which would put you right about there at 0, 6, -3. So you're still moving your x direction first, then your y second, but you move the z direction third. That's your third coordinates, the z direction. So that's really how you plot points in 3D. There isn't much to it. It's like plotting points in 2D, only you have the z-axis to consider. Now, we're also going to sketch the graph of some three-dimensional equations. For example, let's say you have an equation like x plus y plus z equals 7. So now you have a multivariable equation where you have an x, y, and z variable. Well, the idea is you're going to solve it the same. You're going to plot your x-intercept, your y-intercept, and now also your z-intercept to come up with a sketch of what this would look like. So to find the x-intercept, you're going to set y and z both equal to 0. Just to solve for x, you get an x-intercept at 7, 0, which would be right here. So there's your 7, 0. There's your 7, 0, 0 x-intercept. You want to make sure your other two coordinates, your y and z, are 0 when your x is 7. Now how about your y-intercept? You'll set both x and z equal to 0. You would get a y-intercept at 0, 7, 0. So 1, 2, 3, 4, 5, 6, 7. So there is your y-intercept at 0, 7, 0. Because as you know, an intercept is where it crosses that particular axis. Your x-intercept crosses the x-axis at 7, 0, 0. If this were just an ordered pair, it'd be 7, 0. Well, in the z dimension, the z is also 0. And then for your y-intercept, that's where it crosses the y-axis. Your x-coordinate would always be 0. In this case, your z-coordinate will always be 0. And then to solve for the z-intercept, just set x and y equal to 0. You get z at positive 7. So 1, 2, 3, 4, 5, 6, 7 will be right here. You'll label your z-intercept, since your x and y are both 0, it'll be 0, 0, 7. Those all would make up your, this would be your z-intercept at 0, 0, 7. Now you'll just connect the dots. And what do you notice? You actually kind of get a plane. You get a triangular area, actually. You get a very small triangular area between all those. So usually when you have a three-dimensional equation, when you have a three-variable equation, you're going to get a triangular plane. If it were just a two-variable equation, you would get a line. When you're dealing with a three-variable linear equation, you're going to often get a triangular plane. That's an important difference. That's the three-dimensional equivalent to a line. We'll do a few more equations here. I know that was a really small example, but let me build the axis back up here. All right. So we have 5x plus 4y plus 2z equals 20. So we have the three variable linear equation 5x plus 4y plus 2z equals 20. Well, let's solve for the x-intercept first. You'll set both y and z equal to 0 to find your x-intercept, which would give you 5x equals 20, giving you x equals 4. So your x-intercept would be located at 4 for your x-coordinate, then 0 and 0 for your y and z coordinates. So your x-intercept is at 4, 0, 0. Now let's find your y-intercept. You'll set both x and z equal to 0. You would end up getting 4y equals 20, giving you y equals 5. So the y-intercept is going to be located at 0, 5, and then 0 for your z coordinate. And then we need to find the z-intercept, which will set x and y equal to 0. You would end up getting 2z equals 20, z equals 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the coordinate for your z-intercept would be 0, 0, 10. That would be your z-intercept. Now you just draw a line and connect the points. Connect all points, and that's what you get. You get another triangular plane for when you connect these, when you connect your x, y, and z intercepts together. That's what an equation in 3 variables is doing. It's creating a triangular plane. Very seldom do you actually just get a line in space. That's usually going to be if you're working on the 3-dimensional coordinate system and you only have 2 of the variables, would you get a line. But more often than not, you're going to be actually getting a triangular shaped plane. Alright, what do we got next? X plus 6y plus 4z equals 12. So we're going to work with x plus 6y plus 4z equals 12. Well, again, start out by finding your x-intercept. So set both y and z equal to 0 to solve for your x-intercept. That'd be at the point x equals 12, which this is the positive x direction. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So your x-intercept would be at the point 12, 0, 0. That's your x-intercept. Now your y-intercept, to solve for that, set both x and z equal to 0. You would get 6y equals 12, which would put you at y equals 2. So there's the y equals 2. So your y-intercept is going to be at 0, 2, 0. Now let's find your z-intercept, which you'll set x and y equal to 0. 4z would equal 12, z would equal 3. So the z-intercept would be at 0, 0, 3. And then like before, you'll just connect these. And there you go. You have a nice triangular plane between the 3 points. Yeah, so 3D graphing's pretty neat. And obviously computers and artists can do it a lot better than I can, but I'm probably just going to have to erase this whole part of the axis. Dang. It's probably just better I start there. Only a couple more of these am I going to do. Then we'll move on to the final part of today's lesson, which will be a multivariable function. Alright, I think we're about there. Let's do 2 more. So we have half x plus 4y minus 3z is equal to 8. So we've been given half x plus 4y minus 3z equals 8. Well, again, let's start out finding our x-intercept, which means we're going to set y and z, both of those equal to 0. You would just get half of x equals 8, giving you an x coordinate of 16. So let's find that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 would be right here. So you end up getting the x-intercept being at 16, 0, 0. Now let's find the y-intercept. You're going to set both x and z equal to 0. You would get 4y equals 8, giving you y equals 2. So your y-intercept will be at the point 0, 2, 0. Now let's find the z-intercept. You'll set x and y equal to 0, giving you negative 3z equals 8. Well, z would be equal to negative 8/3, which is negative 2 2/3, which would be right about there, giving you your z-intercept at 0, 0, negative 8/3. Now you just connect your dots. And you get a very funny shaped triangular plane region. So yeah, we actually went a little bit into the negative z-axis there. All right, one more. Got one more to draw, and then we're going to move on to the functions of more than one variable. All right, what if we had negative 2x plus 9y plus 3z equals 18? So we have the three variable linear equation, negative 2x plus 9y plus 3z equals 18. Well, again, let's solve for the x-intercept in order to graph this. So set y and z both equal to 0. You get negative 2x equals 18, giving you x equals negative 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there is your x-intercept at negative 9, 0, 0. That would be your x-intercept at negative 9, 0, 0. Now let's find the y-intercept by setting both x and z equal to 0. You would get 9y equals 18, giving you y equals 2. So your y-intercept will be at 0, 2, 0. And then let's find the z-intercept by setting x and y equal to 0. You get 3z equals 18, which would give you z equals 6. So the x-intercept can be, the z-intercept can be found at 0, 0, 6. Now you're just, of course, going to connect the dots. And there's your 3D triangular region. That probably looks the most 3D I've ever seen yet because it's so big. But that's what you get. You end up getting a triangular plane when you find all your intercepts and connect them using a three variable linear equation. Alright, so that's how you graph these 3D linear equations. So the next lesson, when we go to solve systems of equations in three variables, you'll get an idea of what's roughly going on. That'll be where those planes intersect. You'll get the ordered triple where those planes intersect. Now, when you have, so let's do a quick two variable equation review. Let's say you have 6x plus 2y equals 18. You're asked to write this as a function of x. You're asked to solve for y and write this as a function of x. Well, that's easy. You get the y by itself, so you'd have 2y equals negative 6x plus 18. Then solve for y, you would get y equals negative 3x plus 9, which we know y is a function of x. You would end up getting f of x equals negative 3x plus 9. That would be the equation for, or the function notation for this linear equation of two variables. You make y a function of x, right? Everyone's familiar with that by now. What you may not be familiar with is what we do when we have three variables. That's where it changes a little bit. If you have a third variable, so here we have now the three variable linear equation 6x plus 2y plus 3z equals 18. Well, when we only were dealing with the x and y variables, you made y a function of x. Now, when you have the z, you're actually going to solve for z and make it a function of both x and y. Let me show you. So get the z by itself. Get the z term by itself on one side. If you were to do that, you would subtract 6x and 2y from both sides. You would end up getting 3z is equal to negative 6x minus 2y plus 18, right? Solve for z, you get z is equal to negative 2x minus 2/3 y plus 6. Now the notation for the function for z being a function of x and y is going to be f of x comma y would equal negative 2x minus 2/3 y plus 6. That is how you turn z into a function of both x and y. This is considered a multivariable function. You solve for z, make it a function of both x and y. Now you're asked to evaluate also f of 2 of 1. Everybody should know how to evaluate just f of 2 or just f of 1 in a two variable equation. Well, it's kind of the same idea when you have a three variable equation. To find the value of z, which is your f of xy, you're going to take that x coordinate of 2, stick it in for x, take your y coordinate of 1, stick it in for y, and solve. So you would take that negative 2 times your x value of 2 minus 2/3 times your y value of 1 plus 6. Well, negative 2 times 2 is negative 4. Minus 2/3 times 1, that's minus 2/3 plus 6. This could simplify into 2 minus 2/3. So then, let's see, let's just solve this. You would end up having 4/3. The value you should get for f of 2, 1 would be 4/3. That would be your value of z at the point 2, 1. So that's how you solve a function of three variables. And we got more examples of this. Let's say you had negative 2x minus 5y plus 5z is equal to 15. Well, we need to, of course, find the function of xy, which would be z. Solve for z, make that a function of xy. So let's do that real quick here. Let's get z by itself, which means you'll add 2x and 5y to both sides. that would give you 5z is equal to 2x plus 5y plus 15. Now just solve for z. Z is going to equal 2/5 x plus y plus 3. And then last but not least, turn z into the function of f of xy notation. So f of xy would equal 2/5 x plus y plus 3. So there's your function of xy, f of xy. Now we're going to be asked to solve for f of 3/2 negative 2. We're going to solve for f of 3/2 negative 2, and we'll get a value of z. So all you're going to do is plug in 3/2 into your x variable. So you would take 2/5 times 3/2 plus your y value of negative 2 plus 3, which this would simplify into 3/5 plus 1, which would end up giving you 8/5. So f of 3/2 negative 2 would give you a z value of 8/5 when x is 3/2 and y is negative 2. Z is equal to 8/5. I still got more. Alright, this time we have x plus 6y plus z equals 10. So we got x plus 6y plus z is equal to 10. Well, first, let's solve for z and make this a function of z. Make the z a function of xy, rather. Get the z by itself. If you get z by itself, that's going to look a lot like negative x minus 6y plus 10. You'll have z equals negative x minus 6y plus 10, which, as we know, z is a function of x and y, so you would get f of x comma y is equal to negative x minus 6y plus 10. So that's easy enough. You just made z a function of xy. Now, what's the given point they want us to do? We are going to find f of negative 4, negative 1. So to solve for that, you'll put negative 4 in for your x value. So you would get negative of negative 4 minus 6 times your y value of negative 1, all that plus 10. Well, negative 4, that's positive 4. Negative 6 times negative 1, that's positive 6. So 4 plus 6 plus 10, which would end up giving you 20. So f of negative 4, negative 1 is 20, which that would be your z value, would be 20. I know it's weird seeing functions of more than one variable because up till now that's all we've dealt with, but functions, multivariable functions do exist. What if I have 3x minus 3/4 y plus 5/2 z equals 9. That one looks hideous. That one actually looks a little hideous. But we still need to solve for z and make it a function of xy. So get the 5/2 z by itself. That's going to look a lot like 5/2 z equals negative 3x plus 3/4 y plus 9. Multiply everything by 2, you would get 5z equals negative 6x plus 3/2 y plus 18. And then solve for z. Z would equal -6/5 x plus 3/10 y plus 18/5. Yeah, that looks a little hideous, doesn't it? That means your f of x comma y would be equal to -6/5 x plus 3/10 y plus 18/5. So there's your multivariable function, z as a function of x and y. F of xy equals -6/5 x plus 3/10 y plus 18/5. And this time for the point they want us to do, it's going to be f of -3/16. So we got to do f of -3/16. So put in -3 for your x variable. That's going to be -6/5 times -3. Then you have plus 3/10 times 16 for your y variable plus 18/5. Which this is going to equal positive 18/5. Now let's see here. 3 times 16 over 10, that would become 3 times 8 over 5, which would become plus 24 over 5, plus yet another 18/5, which we'll add those together. 36 plus 24 is going to be 60. That would give you 60/5, which would be 12. So f of -3/16 ends up being 12. That would be your z value when x is -3 and y is 16. And I got one more problem, then we'll be done for the day. All right, -x plus 6y minus 9z equals 12. So we have -x plus 6y minus 9z equals 12. Well, of course, let's start out by getting the z by itself. That's going to start out with -9z equals x minus 6y plus 12. Now divide everything by -9, you'll get z by itself. That's going to equal -1/9 x plus 2/3 y minus 4/3. Which means your function of xy, which is z, the f of xy, is going to equal -1/9 x plus 2/3 y minus 4/3. So now we have z as a function of x and y. Now what point do they want us to evaluate this time? They want us to evaluate f of -1/2 12. So let's evaluate f of -1/2 12. So we'll stick in -1/2 where we see the x. So you're going to take -1/9 times your -1/2 plus you're going to take your 2/3 times your y value of 12, then just minus 4/3. Well, -1/9 times -1/2 turns into positive 1/18. 2/3 times 12 would be 8, so that'd be plus 8 minus 4/3. And it seems to me we need to make all of these have the same denominator. So this is going to look like 1/18 plus 144 18ths minus 24 18ths. 144 minus 24 is going to, of course, be 120. And then you have plus 1, that'd be 121 18ths. And I don't think those factor any further, but I'm willing to find out. Does it factor any further? That's always something we want to ask ourselves. It doesn't appear so. So the answer you should get for this would be that f of negative 1/2 12 would equal 121 18ths. So that's it for this lesson. We've learned how to plot points in the three-dimensional coordinate system. We've learned how to graph three variable linear equations, which produces a triangular plane. And then we've learned how to convert z into a function of x and y and then solve for given values of that function. Next lesson, we are going to solve systems of equations in three variables, which, now that you have all this understanding, will help you understand why we're solving systems of equations in three variables and what's actually going on when you do. So I hope everyone has a great day. Take care.